So now we have negative 2 plus or minus the square root of 4 plus 12, 21 times 4, 84, I think. Yeah, 84. Divided by 6. So then x is now equal to negative 2 plus or minus the square root of 88 divided by 6. And then you want to simplify your root as much as possible. So I see that there's certainly a 4 in there. I can write it as negative 2 plus or minus 2 square root of 22 divided by 6. I don't see any more perfect squares under the root, but I can simplify the 2's here, so I can rewrite this as negative 1 plus or minus the square root of 22 divided by 3. I divided all 3 by 2. Okay? And then at this point, since 22 is not rational, you can just leave it. That's fine. Should be good enough. All right, now within the quadratic formula, we have something called the discriminant. And the discriminant tells you how many real solutions you have to a quadratic equation before you even solve it. So the part of the discriminant, or the part of the quadratic formula that is called the discriminant is b squared minus 4ac, and it's set equal to 0. Okay, if it's set equal to 0, this tells you that you have one solution. If it is greater than 0, this tells you that you have two solutions. And if this is less than 0, what you have are either no real solutions, or you can say that you have two imaginary solutions. So again, before you even delve into trying to solve or find the zeros or etc., you can use the discriminant to tell you how many solutions you have. On page 252, there's a little box called Connecting the Concepts. And I think it's worthwhile to spend a minute looking at that, looking at the difference between the linear and the quadratics, and just trying to tie everything together in terms of finding solutions and how that looks graphically. So you could take a second to look at that. It'd probably be worth your while. All right, section 3, third section here. Now we're going to take a second and look at graphing quadratic functions that look like this. Okay, or of the form of that. Now, first of all, the point HK is what we say, this is where the graph turns. It's also called the vertex of a graph. And I think we talked a little bit about vertexes in chapter 2. We also talked about where the graph turns. When it talks about the graph turning, you're talking about where it goes from decreasing to increasing or from an increasing to a decreasing. Okay? Now, the maximum or minimum value of a quadratic occurs at the vertex. So again, from chapter 2, if you have a parabola that looks like this is clearly the maximum value. There is no other point on this graph that's higher. You know, if your quadratic looks something like this is clearly the minimum. There is no point on the graph that is lower. So that point, or the point where it goes from increasing to decreasing, or decreasing to increasing, is called the vertex. Now, each graph has a line. At x equals h, and again, we're pulling from here. If you can get your equation in this form, all of these things sort of pop out. And we call this line the axis of symmetry. And we talked a little bit about reflections in chapter 2, and so what your axis of symmetry actually does is it tells you where your reflection happens, or the line at which the reflection happens over the axis. So if you had a line down the center here, it would be even on both sides and you'd be reflecting back and forth. Okay? Now, we can find the vertex of a parabola by looking at the point the opposite of b divided by 2a, and then the function of negative b divided by 2a. Don't forget that even though this looks a little bit complicated, all we're doing is giving an x-coordinate and then the function of the x-coordinate, or the input and the output, the x and the y. And we're using, or we're gonna find the values for these b's and a's from that generic quadratic formula. So here's your a, here's your b. You plug in those values and you simplify. Okay? So let's take a second and look at an example here. F of x equals the opposite of x squared plus 14x minus 47. First of all, we want to find the vertex. Okay, so we just said that the vertex is going to be the opposite of b over 2a, and then the function of the opposite of b divided by 2a. The first thing you need to do is make sure that your quadratic is set equal to 0. It is. So now, to find the first coordinate, you take the opposite of b, so it's going to be the opposite of 14, divided by 2 times the opposite of 1. So it's the opposite of 14 divided by negative 2, which is positive 7. That's this. Now, we want the function of whatever this result is. So, to find the function of the opposite of b over 2a, what we're actually looking for is the function of 7. We've simplified it. Which is the opposite of 7 squared plus 14 times 7 minus 47. Let's plug it in. I don't have a calculator next to me, so it's going to be old school on the board here. So we have the opposite of 49 plus 98 minus 47. So 98 minus 47 is 51, which is 2. So your vertex is at the coordinate 7, 2. Is there a maximum, minimum value? This comes from just being able to recognize visually what graph goes with what type of equation. I notice that this is a quadratic, and I notice that the first term is negative. What that means is it's going to be an upside down parabola, so to speak. okay? We just found the vertex. That means that's the highest or lowest point. In this case, because there's a negative squared term, I know it opens upside down, I know that this is the highest point. What that means is, I know that the 0.72 is the maximum. It's a great idea to be able to identify at least the generic shape of what graphs look like based on the equations. Part C asks us for the range. Now, we talked a lot about domain in chapter 2. Domain was the x-axis, range is the y-axis, or range are the possible y-coordinates. Again, if we know that this is what the graph looks like, and we know that this point is 7, 2, we know the y-coordinate is 2, you don't have to graph it. We know that the highest it can go on the x-axis is 2, and we know that the lowest it can go is infinity, negative infinity. So our range is going to be the point 2, and then it will go all the way to negative infinity, because it goes all the way down. Part D asks us what intervals the function is increasing or decreasing. We said that when we're looking at increasing or decreasing functions, we're looking at it in terms of the x-axis. So on the x-axis, it is increasing from negative infinity all the way to 7, and it is decreasing all the way from 7 to positive infinity. Increasing, 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 decreasing, decreasing, decreasing. All you need to know in terms of intervals for increasing or decreasing is where the x-coordinate is, where it changes direction, or it switches. It is a really, really good idea to take a look at the rest of the examples, and it's a really good idea to look at page 266. It's called Visualizing the Graph. And again, making sure that you recognize what graph goes with which equation. Sometimes you may have to take the time to plug in points, but most of the time you should be able to look at the equation and get just a general picture of what the graph should look like. So let me give you the answers to page 266. Number 1 is C. Number 2 is B. Number 3 is A. 4 is I. 5 is F. Number 6 is D. Excuse me, number 4 is J, not I. I cannot read. J. Okay, number 6 is D, and then I, and then G. And number 9 is H, and then 10 is E. So, I hope this was helpful. I welcome any feedback you have. It's the first time I've ever done this, so try and be patient with me. And if you have any additional questions, please send me an email and I'll try and either meet with you, or we can do it over email, or we can scan documents back and forth. We'll play it by ear. But again, I hope this was helpful. Have a good weekend. Thanks.